So this is checkpoint module 4 solutions, starting with section 3.1 when we have to graph quadratic functions. Because the square is completed, we know that the vertex is 3, comma 2. We will always plot the x and y intercepts, the vertex. We will always graph the axis of symmetry, which is not part of the graph. That's why it's not a solid line. And we always identify based on the leading coefficient, we identify whether the parabola has a minimum or a maximum. Since the leading coefficient, which is 1, is positive, so then the parabola has this shape, which means a minimum. And this is the vertex, 3, comma 2. How do I know this? Because the graph of x squared shifted to the right 3 and up 2. That's how we get the vertex, as we know from transformations. So the x-intercepts none, of course, because the vertex is a minimum and the minimum value is positive. If the minimum value were negative, then the x-intercepts would have existed, but they don't at this point. Y for this function. So y-intercept, when I plug in 0, 0 minus 3 squared is 9 plus 2 is 11. And x equals 3 is the axis of symmetry. And the minimum value is 2, as mentioned here. And the range is 2 to infinity. Same steps for this function. This function is factorable, which means the x-intercepts will be 5 and negative 3. X-intercepts when f of x is 0, 5 and negative 3. The vertex, because the squared is not completed like problem 20, we need to determine the x of the vertex, which is negative b over 2a, negative from the formula, negative 2 as the middle coefficient divided by 2 times a, which is 1. So this gives us 1. We plug in 1 to get negative 16. X-intercept, as I mentioned, y-intercept when x is 0, 0, 0, negative 15. Axis of symmetry is always the x of the vertex. And the minimum or a maximum, in this case minimum, is always the y-coordinate of the vertex. Because the y-coordinate is negative, as we know, the x-intercepts exist. So here's the graph. And the range from negative 16 to infinity. This was a word problem. We were asked to find the maximum. Of course, we have to find the coordinates of the vertex. So this is the horizontal distance, and the maximum is f of 2. Same thing like we did before a minute ago on the previous problem. F of 0 is 6. So we find the x-intercepts using the quadratic formula, and this is the graph. It reaches a maximum at x equals 2, as we know, and it drops to the ground. Here we were asked to this was a problem in which we were given the fence, the perimeter that was 200, I think it was in feet, yes. So from here we solve for y, which is 200 minus 2x, and the area is x times y, and this is y, and we get this after we distribute and arrange in descending order. It has a maximum since the leading coefficient is negative, and the vertex will give that maximum. So we find negative b over 2a again, and then we plug in and we get 50. So when we plug in back in the function, we get 5,000 square feet. Section 3.2, graphing polynomials. This is degree 4. The leading coefficient is positive, and degree 4 with the leading coefficient that is positive, the function comes from positive infinity and goes to positive, exactly like x squared. This was another function. We were asked to apply the intermediate value theorem because it's continuous, and at f of 2 is this number and f of 3 is this number. After we plug in, the function changes sign. If it changes sign by the intermediate value theorem, there must be a 0 somewhere between 2 and 3. That's all we need to write, nothing else. In order to graph a fourth degree polynomial function, first I factor it to the most, all the factors possible. So we know that since it's degree 4, we have to have 4 x-intercepts. Of course, if they are imaginary, then they don't exist. But we have to look for 4 solutions because the degree is 4. And we see that 2 solutions are 0, multiplicity 2, and that means a turn, either coming from above and going back or below. Now, x equals -2 is the other solution, and x equals 2 is the last one. Because they have multiplicity 1, these will be just regular cross. I specified this here. -2, 0 is a cross, 0, 0 is a turn, and 2, 0 is another cross. So we'll see in a moment when we graph it, because the function is symmetric. F of -x equals f of x, the function is even. So what I graph on this side of the y-axis, I have to have a copy on this side of the y-axis. And we found the max-min with the graphing calculator. So how did I graph this? I started at -infinity. I see it crosses at -2, 0. It has to reach a maximum because it has to turn, come back to 0, and turn again. It cannot turn at 0 if it does not turn again or has a maximum up here. And once I'm finished, I only have to copy on the other side. And how do I determine the maximum with the graphing calculator? The graphing calculator, where is my graphing calculator? Here it is. So you enter the function in y equals, and the function is -x to the 4th, and then plus 4x squared. And then we go to, I know that the viewing window should not be more than -4, 4 with a scale of 1, and -2, 6 with a scale of 1. So window, -4, 4 with a scale of 1, and -2, 6 with a scale of 1, and I press graph. I see the graph. That's exactly what I had. Only check with the graphing calculator. Do not rely on the graphing calculator and copy the graph, because you're not going to get credit, please. Okay, so I only need to determine this maximum. And I know it's somewhere between -2 and 0. -2 for x and 0 for x, right? So we go to second in calc, and I want to determine the I want to determine the maximum, and press enter. It will ask us to give a left bound. I will give -2 the left bound and 0 the right bound. And then just press enter. And it will give us as -1.41, 4, and the other one is 1.41, 4. And I put them in the table. And this is a relative or local max. This is a relative of or local minimum, and this is the relative or local max. Everything is the same for degree 5. The same thing, 5 solutions. However, these two are not real, so they will not be graphed. They don't exist. All the steps are the same. F of -x equals -f of x. I determine the x-intercepts, and they're here. They're all crosses. 0 appears once, and these 2 appear once. Cross, cross, cross. Okay, so after we graph, how do I graph? Coming from positive infinity, it crosses at -2, 0. It has to reach a minimum. It comes back, it crosses at the origin, it reaches a maximum, and comes back down to negative infinity. Oops. Sorry about that. Please make the correction, negative infinity here. So you can graph again, graph with the graphing calculator. You can determine the minimum and the maximum. So the graph function is -x to the 5th, and then minus x to the 3rd, and then plus 6x. Again, I already calculated this before, so I know the viewing window is fine, so I just want to graph. The viewing window is not fine, so I just have to adjust the y minimum to -6. Okay, so I see that this is the minimum, and I will repeat second and calc, and the minimum, which is 3. It's between -2 and 0. So -2, the left bound, 0, the right bound, and it will give us the minimum as -0.91, comma 4.1. -4.1. Of course, because the function is symmetric with respect to the origin, this point translates up here with both positive, both negative here, both positive there. Next problem, the same thing, everything the same. I got multiplicity 2 for x equals 4, that's why it's a turn. And 5 and -5 are crosses. We determine the x, the y-intercept, which is a huge number, and degree 4, the end behavior, because the leading coefficient is negative, that's the end behavior, and we determine the max and the min with the graphing calculator. Same thing. Then long division. The long division makes sure 2 things, that both polynomials are in descending order, and secondly, that the polynomial, this polynomial and this one, the numerator and the denominator, make sure that there are no missing terms. If they are missing terms, then you have to leave a blank space. Well, there was no missing term, so 3x times y is 6x cubed. That's positive 2x squared. We multiply these two, we have to change the sign. We multiply, we distribute here, we have to change the sign. -4x squared. So combine like terms. So 17 minus 8 is 9x squared. 3x times y is 9x squared, is positive 3x. Go back. Positive 9x squared, subtract. We always have to change the sign when we write underneath. So 3 times 4 is 12, change the sign. So 27, of course, I brought down 27. So this is gone, and here we have 15x. Bring down the next in line. 3x times what is 15x? Positive 5. We do not lie at the top. So 5 times 3x is 15x, but I have to subtract. 5 times 4 is 20, but I have to subtract. And there is no remainder. In the same way, here I wanted to show the long division and the synthetic division, just make sure that you get the same thing, so you can always repeat the steps. And now using the synthetic division, because we are dividing by x plus 6, the box gets x minus 6, in other words. So x plus 6 is written as x minus -6. Synthetic division only works for p of x divided by x minus a, and we have to determine a and put it in the box. So therefore a is -6. And careful with the coefficients. 1, -6, 1, -6, 0. Degree 4, degree 3, degree 2, degree 1, and degree 0 is missing, so 0. We bring down 1, we multiply, we write the answer. We combine like terms, -12, we multiply, we put the answer at the top, 1 plus 72 is 73, we multiply, we get -438, we add -444, we multiply, and this is plus 0 is the remainder. So, because the degree was 4 at the top and 1 in the denominator, this must correspond to degree 3. This must correspond to degree 2, degree 1, degree 0, plus the remainder over the divisor. Now here we were given an equation and we were told, well, x equals -2 is a solution, which means just x plus 2 is definitely a factor of this polynomial. So when I divide this polynomial by x plus 2, I have to get a remainder of 0. So bring down 2, multiply, get -4. Add -7, multiply 14, add 3, -2, 0. So now this I know how to solve using the quadratic formula or factoring, and I get the other two solutions. I hope this helps.